Welcome, welcome. So this is Angie with Angie's Beyond the Lecture, and this is, I believe, the eighth installment of our chemistry final review, and it's part of the foundations of chemistry. So it's sort of the first quarter to a third of the chemistry semester, whether you're in high school or intro to college chemistry or even Gen Chem, General Chemistry 1. The foundations are the same across the board. However, as you progress, of course, you are going to see more complicated material in college. But for the most part, certain topics such as dimensional analysis and unit conversions are going to be the same across all of these courses, whether you're in high school or college. So to step right into the topic at hand, we're going to talk about dimensional analysis and unit conversions. So this is a core feature of chemistry where you need to be able to convert between one quantity to another. So I'll give a very common example. You have grams of substance and you need to put it over into moles of substance, or perhaps you have kilograms of something, but the formula wants it in grams, or vice versa. Maybe you have 100 grams of a particular substance as a reactant, or maybe a solvent, and you have to put that solvent into kilograms because that's what the formula calls for. So bear in mind, converting, especially when you're working through word problems, is all over the place. And as you kind of go through the chemistry semester, I would say a good month or two in is where the teacher introduces this concept, and it throws a lot of students off because you're dealing with ratios and converting one quantity to another quantity, and sometimes you have to do multiple steps, and it can get hairy and confusing pretty fast. So we'll go over the two main types of dimensional analysis. Now, we have dimensional analysis, which is, to me, technically it's the method scientists use to convert one unit into another, and we apply conversion factors as ratios. So that's the technical definition, right? But keep in mind, we're just taking one quantity, putting it into another. To simplify it, I love to use the basic, I have a dozen donuts, right? I immediately know one dozen has a quantity of 12. And unless you're dealing with a baker's dozen, that's 13. But if we just assume one dozen is equivalent to 12 units of anything, I know I have 12 donuts. If I have 2 dozen donuts, then I have 24 donuts. And that's simply applying a ratio, right? So going back to, and I'll show a couple of different conversions as we apply it here. And of course, we also have metric conversions. So that's just taking, for instance, a quantity. Maybe I have 100 kilometers and I want to switch it over to meters. We could be going from a larger unit to a smaller unit, or perhaps I'm going from a smaller unit up to a larger unit. These numbers down here look a bit off, and that will be fixed here. But going back to the first part, we'll go through a couple of different conversions, so to speak, and then we'll talk about our metric conversions and how we can do that. I have 3 fundamental ways I show students, 2 being ones I favor, the other I don't favor. And I'd like, in this particular video, I'm going to show you how to use this particular chart to help you in this quest. And then in the review, I'll show you how to use ratios, applying ratios to find your conversions. So down here, and I'm just scrolling down here so I can find a blank page. I know I put one in here. Okay. So if I give you, for instance, I want to take 32.2 inches and I want to convert it to feet. Okay. So we know there are 12 inches in 1 foot, and inches are smaller, right? They're a component of feet. So I should know that we'll have a smaller number as a result, right? But let's do the math and make sure we understand how to do this conversion. So I know one foot equals 12 inches. And you'll probably, a lot of times, especially in like, for instance, the gas laws unit, we use different units for pressure. We use millimeters of mercury. We also use atmospheres. We also use pascals. There are several different ways to measure pressure. And unfortunately, there are several different units, and we need to convert amongst them. So I'll give you an example of that as well. But a lot of times you'll just be given the equivalency statement and you need to put it in a ratio. So how we do that is we just say, okay, 32.2 inches. And I know I have 12 inches. Whoa. And 1 foot. I'm just going to abbreviate that inch. And make sure you cancel. You should be able to cross cancel those units and end up with, we have a quantity of 32.2 divided by 12. That's 2.68, repeating 3 feet. And if I were to answer this in the appropriate number of sig figs, I would say, okay, this is 2.68 feet and call it good. Okay, so if I have 32.2 inches, I know I have just over 2.5 feet, and that should make sense, right? We have a yard is 3 feet, and that's 36 inches. So yeah, we're just short of 3 feet, 2.68 feet. Always, I can't stress enough, always take a look back or take a step back and look at your answer. Make sure it makes sense. All right, let's do a couple more conversions as examples, and then we'll go back and look at metric conversions, and we'll be done with this particular section. Now, in the gas laws unit, I am given the quantity that 1 atmosphere is equivalent to, apologize, 1 atmosphere equals 760 millimeters of mercury equals, and I apologize, I'm going to move my computer down here, equals 760 torr. Okay, we'll keep it there. I'll correct that M here. So we have 1 atmosphere equals 760 millimeters of mercury, which equally converts to 760 torr. So what I like about this particular part of the unit is that if I have 760 millimeters of mercury, or the mmHg, I also have 760 units of pressure in torr. Now, as a side note, torr is short for Torricelli. He was, and I think he was an Italian scientist, and that unit was named after him, in honor of him. And what I know about millimeters of mercury and torr is that they're 1-to-1, right? So if I have 60 millimeters of mercury, I also have 60 torr. I love it, but we can't use that. We can't use that concept when we're working with the other pressures. So if I know, for instance, if I'm given, okay, I want you to take 2.5 atmospheres and I want you to put it into millimeters of mercury, I need to apply a ratio. Well, to do the math, I just say 2.5 atmospheres and I'll apply my ratio. Well, I know 1 atmosphere is equivalent to 760 millimeters of mercury. And I need to figure out what's going on with my pen. All right, so 2.5 times 760. That is exactly 1900 atmospheres. Or I'm sorry, millimeters of mercury, my bad. 1900. I apologize. I don't know what's going on with my pen here. Maybe I think I'm pressing too hard. Or things like, don't. So anyway, we have successfully converted 2.5 atmospheres to 1900 millimeters of mercury. This is, in a nutshell, how we convert one unit to another. Again, we did inches to feet. It's a common concept you might see in chemistry. especially in the intro days. And then later on, we'll take atmospheres over to millimeters of mercury or torr. We also have other units like you can even do inches of mercury, and you can do pascals as well. So that sums up this particular part of this video. I'm also going to discuss as I scroll up here, as I'm talking, yeah, we're going to look at metric prefixes and how we can easily convert. And I'm going to use this chart as the foundation for doing that. But I need just a quick moment because I have a cat staring at me right now, and she's interrupting my video. So I'll be right back. Oh, honey, come here, come here, come here. I know. Metric prefixes. I collected all of them from our base unit. Our base unit's right in the middle. I'm going to circle that real quick. And to our left, we have the larger units. So common examples, like we see kilo a lot, like kilometers, megahertz. That's actually a physics thing, but we put MHz, right, for megahertz, and radio frequencies and things like that. We even go up to tera and giga. So, that essentially means we are multiplying whatever value we have by a factor of 10 to the 12 power. That's 12 zeros right there. So that's got to be what? Trillion? Tera would be trillion. Now, if we go to the right, we have deci, centi, milli. Okay, so centimeters, that's a common prefix. We know there are 100 centimeters in our base unit of meters. And we did touch on that in earlier on our base units, right? So we have meters, we have liters for a base unit. What else do we use? Chemistry would also have maybe joules. Yeah, right here, joules, kilojoules, and so on. And nanometers, that's for wavelength down here. Okay, those are common examples. I'll get back to those in a second. Now, when we keep going right after milli, we also have micro, nano, and even pico. So this section right here, this is your microbiology, microchemistry. Micro 10 to the -6. We use that in our biochemistry lab work. Nanometers, that's commonly used for wavelength. Picometers, that's going to be so tiny that deals with your atomic radius. All right. So I pretty much captured everything in the list below. Common prefixes in chemistry. Kilo on the joules for kilograms. Deci and centi, we might see centimeters or maybe even deciliters. Milli, millimoles, millimolar for volume, or sorry, millimolar for concentration. That's our mm right there. Milliliters, and then milligrams. Milligrams, like for medication, right? Those are smaller doses. Micro, that's common in labs with our microliter. We use a little pipette for that. Nano, again, wavelength. And wavelength has to do with the electromagnetic spectrum and the colors that we study, the colors of light, visible light. And pico, atomic radius and bond length. So that's like ultra, 10 to the -12. That's ultra tiny. Can't see that with the naked eye. Now, tips for converting. I'm going to sum it up in here, and after I delete this whole page, or the writings that I put on this page. So one moment. Okay, thanks for waiting there. I'm going to sum up this particular part right here verbally in these two examples. Now, if I have, for instance, 253 centimeters and I want to move it over to kilometers, so I'm doing a conversion and I'm using this chart. Again, I will show you how to apply ratios and get to the same end number or in quantity that you want. And I'll show that in the review problems that we have at the end of the series. What we have to do is when we go back up to the chart, so we're taking centimeters to kilometers. So we're actually going from here, I'm just going to point that arrow all the way over here, and I'm jumping 1, 2, 3, 4, 5. I'm jumping 5 powers of 10 from right over to left. And that's exactly how many steps or decimal places I'm going to take from the 253 all the way over to our kilometers. So starting with 253 centimeters, I just need to jump 5 decimal places to the left, and I will have the correct quantity in kilometers. So I'm going back to my example here. And I even wrote out, okay, start with 253 centimeters. And of course, we have our little implied decimal there. We don't normally see it unless we need to use it. We're going to convert to kilometers. A move from centi to kilo is 5 powers of 10 to the left. So if I start here, I'm literally going 1, 2, 3, 4, 5. So you notice to the right, I'm setting up the actual answer here. And I'm demonstrating the hops via the pencil, and I'll take it off just so you can actually see it a little bit better. And I'll zoom in. Here we go. So 253 centimeters converts to 0.00253 kilometers. There you go. That's it. That's done deal. Now, again, I'm going back up to this chart. This is assuming that you can actually list out, or either you have this chart available on a quiz or test, or you can actually, you know the spacing of all of the metric prefixes. And it's critical to know what prefixes you need to know. When I took general chemistry, I was expected to know all of these, you know, tera, giga, mega, kilo, all the way down to pico. If you're in high school or maybe even intro to college chemistry, you might just need to know maybe here to here, right? So it's essential to know what prefixes you are responsible for memorizing. And I would just, if you're taking a test or a quiz, is just crank them out from left to right. Make sure you have the larger prefixes on the left, smaller on the right, and you just simply move however many decimal places you need to go from one to the other. Now note, there is a jump of 3 here as well as a jump of 3 here. You know, so basically after those inner kilo all the way down to milli. So I'll back up here for just a second for clarity. I have from kilo to milli. Each move from left, whether you go left or right, is 1 decimal place. But once you get out either here or here, each jump is 3. You just have to remember that. So going from kilo to mega, that's actually 3 decimal places, not just 1. Okay, so that's to me a tried and true way of actually moving between your metric prefixes on a given base unit. So this is an example from a smaller to larger unit. Again, we took centimeters to kilometers. Let's take, this one's pretty big. I went all the way from mega to micro on the second example. So I took 26.4 megameters and converted it over to micrometers. Now that's a pretty extreme jump, but you just never know what you might see on a quiz or test, especially in general chemistry now. But if we go back up to our chart, which I'll do real quick, we have mega to micro. Remember mega to micro. And so we're starting here, the arrow there, and we're ending up here. Okay. So we're taking 3 jumps from 6 down to 3, and then 4, 5, 6, 7, 8, 9, and then another 3. That would be 12, right? 12 powers of 10. Okay, good. Yeah. So we have, back down here, we have a move from mega to micro is 12 powers of 10, or 12 decimal places. So we simply need to take that decimal, and if you move it once, like I did right here on the left, and then you would just add 11 zeros, okay? And so ultimately we end up with, and I'll just go ahead and confirm it here, 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11, 12. Voila. There we go. So 26.4 megameters converts to, we're looking at what? Trillion? 26 trillion 400 billion nanometers. Wow. That's something else. Now it should make sense if you have one large unit like mega, that's a pretty large unit, and you're converting to a smaller unit like micrometers, you're of course going to have a way large number. One large unit contains a lot of smaller units, okay? So that's it for this section. And I also made a note here for those of you who are reviewing the notes that implied decimals are shown here and here, you know, just to show where it either started or where the decimal point landed. Yeah, I actually showed it here and here as well. There you have it. Thanks again for sticking with me and working through conversions. I'm just scrolling to the back here to do a quick recap. We did dimensional analysis. We worked on some pressure conversions, inches to feet. Those are just your standard one-step conversions. We also worked some metric conversions, and that's just knowing the spacing between all of your prefixes, okay? So again, this banks on you knowing your prefixes and your powers of 10 and just maneuvering left to right, okay? And wherever you start and end, you're just simply moving that decimal place over to the left or to the right. To me, it's intuitive, okay? It might not make sense to you all, and I will show you 2 additional ways to negotiate metric prefix conversions should you run across that in a test and you just want to use the simple ratio method as well. All right, thanks again for watching.